Hello everyone. So I hope that everybody has already watched our previous video on our angles in quadrilaterals, because I think it's actually quite important for us to understand some basics so that we learn how to apply to future questions that we encounter in PSLE. Such angles questions actually come out very regularly. In fact, almost 15% of our questions in PSLE is always related to angles. So it's best to be prepared for all these types of questions. So let's start off with our first part, where we are finding, again, in this rhombus here, ABCD, your DFB and DECG are all straight lines. Now, find angle ABD. So where is angle ABD? If we notice, it is this angle here. And how is this actually easy to determine? It is actually based on the properties of your rhombus, where you have four sides being equal. And the moment you see four sides being equal, you actually see our isosceles triangle here. So based on the isosceles triangles, we can already determine the angle ABD. Angle ABD will just be 180 minus 106, and we divide the value by 2. This will allow us to go and get the answer of 37 degrees. Very quickly here, because it's based on your isosceles triangles. Okay, so it's important to take note that within your rhombus, we did talk about our isosceles triangles, and the moment we see rhombus, please prepare for that. The second part is actually on your GCD. And GCD, as you would see here, is actually outside of the figure. Now, again, how is this actually quite easy to be determined? We have so many methods that we can apply for this question. So we can actually start off by using this angle, 106, and starting to look at all other familiar angles around. 106, we can actually link it to this angle, then to this angle, or we can even look at the opposite angle as well. If we look at this angle, some of us can even go by this way first, then here at the bottom. You can see already 3 different techniques. Do not ever limit yourself to any of these angles here. We can still explore many different ways to go and solve. So let's go with the more traditional kind that is easier for students to understand. We can use angle ADC first, which is 180 degrees minus 106 degrees, giving me 74 degrees. So how is this 74 degrees helpful? Because this 74 degrees is then a corresponding angle to your BCG as well. So GCB, we can take 74 degrees, exactly just like that, and we can just write a very simple corresponding angle right beside. Okay, so it's best basic corresponding angles, very helpful for us to understand. Last but not least, your angle EFB. So where is angle EFB? It's also given to us over here. So some of us may be thinking, I see another quadrilateral, BCEF inside. We can use that to do the calculations. However, do we really need to? We can even consider using things that we already have to help us solve. So rather than just looking at that angle itself, we can look at neighboring angles, such as the angles on the straight line, where it's then again linked to your triangles here. Finding the angles inside the triangle is actually rather simple as well. We start off by first finding your angle BDC, which we know it's going to be 37 degrees, based on the properties of your rhombus again. So here is 37. Okay. The second part is to find the neighboring angle over here, your FED. It's based on 180 degrees minus 54 degrees, giving us 126 degrees. So how do we get this 126 degrees? This is based on your angles on the straight line. From here, we can then relate back to our angles that we are focused on, which is this angle over here, DFE. And some of you, if you also know about your exterior angles rule, you can use that straight away to calculate BFE. However, it's not a method that is commonly taught in school, so again, we'll focus more of the basics. We look at angle DFE first, and angle DFE is just 180 degrees minus 37 degrees minus 126 degrees. Angles inside your triangle, allowing us to go and solve the angle of 17 degrees. And last but not least, back to angle your EFB. Angle EFB would be 180 degrees minus your 17 degrees to give us a final answer of 163 degrees. Angles on the straight line, then we managed to get the final answer, 163.